Intel Smart Edge is an edge computing software toolkit that enables highly optimized and performant edge platforms to onboard and manage application and network functions with cloud-like agility across any types of network. Currently, Smart Edge is divided into two release channels. One is through the open source channel release of Smart Edge Open. The other is for commercial partners to build the commercial Smart Edge. The Smart Edge building blocks are built on a solid cloud-native foundation that includes Kubernetes, Service Mesh, telemetry, and so forth. It uses Helm and the Kubernetes operator framework, making it easy to deploy on standard Kubernetes clusters. Smart Edge offers several key benefits. It's optimized for edge KPIs like throughput, determinism, and latency. It's multi-location, multi-access, and multi-cloud. Smart Edge is delivered via use case-specific reference architecture for ease of consumption and to accelerate time to market. It supports various industry standards such as 3GPP, CNCF, ORAN, and ETSI. Some of the top use cases include cloud-native 5G radio access networks, 5G user plan function, SD-WAN, and various MEC applications utilizing AI and media.
This page shows distributed AI platform based on Ray. What's the Ray and OpenVINO? Ray is a fast, simple distributed execution framework that makes it easy to scale your applications and to leverage state-of-the-art machine learning libraries. Using Ray, you can take Python code that runs secretly and transform it into a distributed application with many code changes. And OpenVINO is AI inference applies capabilities learned after training a neural network to yield the results. The Intel distributed OpenVINO toolkit enables you to optimize, tune, and run comprehensive AI inference using the include model optimizer and runtime and develop tools. The right diagram is a pipeline of the distributed AI platform built on Ray. The network communication is based on 5G RIC, and a microservice application platform is built on it to facilitate the interaction between the user and the backend, and the core devices for the distributed machine learning. Distributed machine learning is mainly based on Ray framework and optimized through OpenVINO for inference. The whole process can be built and controlled on the monitor service. After the model is built successfully, it can be downloaded through the one page and provide a series charts and reports to show the performance data.
Ceph is an open-source, highly scalable, distributed storage solution for block storage, shared file system, and object storage with years of production deployments. Rook is an open-source cloud-native storage orchestrator that transforms storage software into self-managing, self-scaling, and self-healthing storage services. The storage systems that are supported by Rook include Ceph, Cassandra, and NFS. Ceph CSI is integrated with Rook and enables two scenarios. RBD driver is optimized for read-write once pod access mode, and Ceph FS allows read-write many with one or more pods, accessing the same storage. For Rook Ceph cluster maintenance, there are three methods to configure Ceph: Toolbox with CLI, Ceph dashboard, and advanced configuration via config map.
Our AI-empowered infrastructure are distributed framework based on Ray and Smart Edge Open, which include 5 parts. The first part, distributed computing pipeline based on Ray. The second, benchmarking and performance optimization based on Intel hardware. The third, offer the Kubernetes operator alignment to Ray clusters. The fourth, enable the Serve framework, an open-source software distributed platform to implement object storage. And last, enable RIC, It is a suite of the software application to enable the SDN functionalities in RAN network. This page shows the whole of the pipeline of our framework. The data from the 5G rig microsurface to the pipeline through the data parsing and data analytics, and we will use OpenVNO to do the high inference. But sometimes we will go back to retrain on our distributed AI platform based on Ray. We offered a Kubernetes operator to configure the hardware resource for each AI workers to different pods. Also developed one scheduler to distribute the AI workload to different nodes in different edge clusters, which were remote to use hardware resource in the Connect computing platform in this edge cluster. Also get max the hardware resource usage. The Surf cluster provides shared dictionary service to read workers through the Surf CSI plugin, and multiple workers can be read and write to the Surf shared dictionary concurrently. Surf also provides object storage service, and AI workload can be accessed through the S-Ray and Labrador's interface. We have one demo how to deployment of the distributed AI and storage on Ray and Smart Edge Open framework.